So we are going to get started. Thanks a lot for coming, and thanks TiEcon for giving this opportunity. So my introduction, I'm Pramod Gosavi. Studied IIT, did engineering for a long time, and then moved on to the darker side, which is investing and strategy. So currently, I'm an investor at Blumberg Capital. So we are an early stage firm. We have a big track record of partnering with Indian founders. So we were the first check in Nutanix, Checkpoint with Ashim, Chandana, and currently we are investors in Nextla, Shabodhi, Angle Health, CloudFuse, and Talent. So my interest area, AI, data, cybersecurity, fintech, SaaS. So these are some of our portfolio companies, and would love for you guys to reach out. If you guys are thinking of starting a company, happy to help. So today's session is on AI and cybersecurity. So I want to start with two different types of AI, and the reason I start here is in cybersecurity, both types of AI are very relevant. So far we had predictive AI, which is on the right side, which is what we call as machine learning. So a machine is learning patterns, and some of the use cases, like fraud processing, autonomous driving, loans. And in cybersecurity, mostly what you see right now is anomaly detection, and the second one is object recognition to fingerprint devices. So those have been the big use cases of predictive AI in cybersecurity, that is anomaly detection and object recognition. But mostly what predictive AI is good for is known knowns, anything that you know that you can model. Machine learning is very good at it. What it was not good at it is analyzing unknown, like something new that came up just right now, and that's where generative AI comes in. So I'm really excited with this technology and the use case for AI. Yeah, I don't know what happened here, but just a crash course, like what is an LLM? So LLM is literally a huge, deep neural network. So on the left side, you take all of the data, like it's a huge amount of data, like everything from the internet to Reddit and Twitter, all of the social media. And then you literally create models out of it. You try to predict the next token. And the use case out here is, information extraction. So, for example, you can ask, like, hey, what did Shakespeare say in so-and-so novel? And it actually has all of that information. The thing I want to stress is, like, there are two parts of LLM. One is, like, information, and the second one is intelligence. So information comes from the data. So when you ask, like, hey, tell me something about the Shakespeare novel, that's information. The intelligence actually comes from being able to predict something. So if I want to write a poetry in a Shakespearean way, I can say, hey, this is my poetry. It's written in common English. Rewrite again in Shakespearean English. That's where it's intelligent enough to go and rewrite it in a Shakespearean English. So those are the two unique parts of LLM. One is the information, and one is the knowledge. So there are huge use cases in cybersecurity that's very interesting. Starting with threat detection. So LLMs are very good at going through a huge piece of data and understanding, and that's what I was mentioning previously. It's really good for unknown, like something new that humans just cannot go through a huge log files and data to understand. So threat detection is a very good use case. The second one is phishing. So this is both AI actually causing phishing as well as you using AI to detect phishing. The third one is incident response. This is more of a traditional automation use case. Vulnerability management, same thing, looking at a lot of data points and figuring out the connections between the entities. Identity and access management, this is a very interesting use case, and we'll have Subbu mention about this. So one of the problems with identity access management is just tracking people and tracking devices, how things change. And we have never been able to actually track that over a period of time, and LLM is a very good use case for tracking behavior. Data security is huge, actually. So previously, you had regex-based classifiers looking at PII data, PCI data, but with LLMs, actually, you don't need to actually even explain what a financial data looks like. You just give some examples, and with one-shot learning, it can actually figure it out. So even you have all sorts of rules and regulations say, hey, the employees shouldn't do X, Y, and Z, and you can just tell an LLM at a very high level, and it will go and create rules and models for that. Pen testing is a huge use case. I'm very excited about that because you must have seen like tools like Cursor and others, so it can actually write code now, so it can understand code. So now, since it can understand code, it actually can test it much better, so it can figure out what's insecure code. Automation, similarly, big use case. Cybersecurity training, this also I'm quite excited. So now you can run a whole bunch of real-time exercises, actually, like say you're sharing some information on your email or your WhatsApp or chat. You can add this chatbot that will warn you not to share too much information. So this one I'm quite excited about. And AppSec will have a Pixie present. So there are a lot of use cases along with design reviews. So design reviews is a use case with multimodal models where it can actually look at PDF files. It can actually figure out your architecture, and it can tell you whether you have an unsafe, insecure architecture. Bug fixes is a huge use case right now that is helping developers quite a bit. So I just want to write about this slide. So there's a lot of debate in the cybersecurity industry about LLMs and hallucination, how good LLMs are. So previously I mentioned, there are two parts of LLM. One is the information, and the other one is knowledge. On the left side, you see like a traditional LLM, like a Llama or a GPT-4. It's trained from a huge corpus of data, but it has a lot of stuff. So for example, when you ask about a virus, it doesn't understand a computer virus versus a COVID virus. So that's a problem on the left side. So how do you actually make it relevant for cybersecurity? So there are two schools of thought is, go train a new model with only cybersecurity data, which is, your corporate data, your knowledge base, your virus information, so it knows that there's only a computer virus, there's no COVID. But it will lack the intelligence. The intelligence actually comes from the right side, which is learning. So the way to explain this is, so think on the right side, a traditional LLM is when you study up to 12th grade. You take a lot of classes in English, biology, chemistry, and you absorb a lot of knowledge. A lot of the knowledge doesn't stay with you, but you become intelligent. You know how to figure out patterns and context and everything. But that doesn't get you a job. You still have to do your graduation or a master's to get a job. So the thing on the left side is your graduate degree, like your bachelor's degree and a graduate degree, where you are learning specific information to actually apply on the job. And that's where the industry is right now is, you take a general purpose LLM model, which is smart and intelligence. So either you can limit to the corporate data using RAG. Most people are there right now is RAG is a huge use case, but longer term we'll see some fine tuning with the corporate data that you have on the LLM side.